Hey, Newbie Dan here. I'm going to show you how to build this lever-operated router lift. It uses miter tracks and runners, along with a lever and skateboard bearing, for smooth and rock-solid operation. I'll show you how to build it for both plunge routers and fixed-base routers using plans on my website. I'll show you how to avoid some common mistakes and how to fix some other common mistakes. And if you don't currently have a router table, I'll show you how to use this lift as a mini router table. So if that sounds interesting to you, stick around. If you want to build this lift, get the plans from my website. The plans tell you what to do, and if you need help with how to do it, there's links back to this video right to the relevant section. So if you don't want to watch this video all the way through, I won't be offended. Just get the plans and jump back whenever you need to. If you're a newbie, this may have never crossed your mind before. If you're a veteran, consider this a 30-second reminder. Is your blade really at 90 degrees to your table? And if you use a crosscut sled, is it 90 degrees to the sled? If it isn't, you can end up with something like this. And if your crosscut sled isn't cutting true 90-degree corners, you could end up with something like this. Okay, hopefully not. Is your fence aligned properly? So many problems can be avoided by spending just a little time preparing your equipment before you start a project like this. If you need help, check out my videos. There's 4 main components here. The housing, which includes the miter tracks, the carriage, which rides up and down in the miter tracks, the mount, either for a plunge router or a fixed-base router, and I'm grouping the bearing, fulcrum, lever, and clamp into a 4th group. The first component to build is the housing, so cut the parts according to the plans. You need to use good quality hardwood plywood, like this Baltic birch plywood that I'm using. That's because we'll be doing a lot of butt joints with screws going into the end grain, so the plywood needs to be strong enough to hold them. By the way, a lot of the clips in this video are sped up. Normally I display something to show that, but it just got too distracting in this video. Anyway, after you cut the parts, label them. I'm using a felt tip pen so it shows up better in the video. Maybe that wasn't such a good idea. To make sure the miter tracks are perfectly perpendicular, we're going to put them in dados. And to make sure the miter tracks are aligned with each other, we'll cut both dados at the same time with the same edge against the fence. This way, even if we don't get them in the center, they'll still be aligned to each other. There's lots of ways to cut dados, but I'll show you a way that anyone with a table saw can do. Set the blade height to something shallow, like around 1/8 of an inch. I've got the part labeled housing side right, and I marked where the dados should go, including on the end here. Put the edge marked back against the fence and the side with the label face down. So when we assemble the housing, we'll know how to align the dados to each other correctly. Set the fence for a cut down one side of the dado and make the cut. Then, without moving the fence, make the same cut in the other housing side so both dados are in the same place relative to each other. Set the fence for a cut on the other side of the dado. Don't make it too wide, it's better to err on the side of too narrow. Make a short cut and see if it's the right width for the miter track. If it needs to be wider, try it again until you get it right. And when you've got it in the right place, make the complete cut. Then, without moving the fence, cut the other housing side in the same place. Start moving the fence in, cutting out a portion of the dado and repeating the process until you clear out the entire dado. Once that's done, test it with the miter track. In my case, it's not quite wide enough, so I cut it a little wider. And dang it, wouldn't you know it? I made it too wide. I highly recommend you don't make this mistake, but I'll keep going and show you how to deal with it if it does happen to you. But regardless, since I've widened the dado, I need to make this cut in the other side before I move the fence. Then finish up by clearing out the dado. I finished marking the housing sides according to the plans. Now it's time to install the miter tracks. I'm using miter tracks from my local Rockler store, but you can find miter tracks from various sources, and I'll include links in the description below. The tracks are aluminum, and you can cut them with just about any type of saw using normal saw blades. and you can drill and countersink holes just like you would with wood. Here's the tracks I'm going to use for this build. As you can tell, I've used them before, so just ignore the middle holes. We only want to use 2 holes in case we need to shim the tracks. So if you make the dados a little too wide like I did, use some paper to push the miter tracks against one side of the dado. For some reason, the other dado isn't too wide, and that bothers me a little, but I'm hoping it won't matter. Don't forget to make sure the heads of the screws are below the bottoms of the miter tracks so the runners can ride smoothly. We're ready to assemble the housing, and we want all our joints square and flush. Not like this, because the carriage would be too loose at the top. And not the other way around either. So, to help me assemble the parts square and flush, I'm using this corner clamp, which I built in a previous video. I've got one side in the clamp. Here's the edge labeled back, and I put the back piece up against it. I take a little time getting the pieces square and flush, and tighten down the clamps to keep them there. It looks good all the way up and down, so I drill and drive the top and bottom screws, then the ones in the middle. And with the clamp, I don't have to worry about accidentally moving the parts. Now I'll do the other side. I'm using some scrap wood to keep the pieces level. I get everything square at the bottom, but the top is a little off. Probably a slight bend in the boards, or something like that. If it happened a lot, I'd go back and recheck my equipment, like I showed earlier. With the bottoms of the pieces aligned properly, I drill the bottom hole and drive the screw so the bottom stays flush. Then I use the smaller corner clamp from the clamp video to hold the top square and flush. Once I get it clamped, I know the pieces won't move on me. I attach the front brace by flipping everything over and using the clamp again. It's just as important to get this right as any of the other pieces. I lay the lift on its back so I can get the base aligned flush with the back. Since I got the sides assembled squarely, there's no alignment issues with the base, and I can go ahead and finish all the screws. So if you ignore the scribbled out labels, this is a pretty clean looking housing. Everything is nice and even since I made sure my equipment was set up properly, and I took the time to join the parts, all together now, square and flush. Next up is the carriage. We'll cut the sides and runners first. Cut both carriage sides at the same time to make sure they're the same width. It's very important to cut them to the same exact length, so I'm using a stop block. I've got this sheet of 3/8 inch UHMW plastic for the runners. Cut 2 pieces to the right length, then cut 1 to the right width by sneaking up on the cut. So keep checking the width against the miter track. It has to have a Goldilocks fit, just right. No side-to-side movement, but it needs to slide easily in the track. And eventually I get it just right. Then cut the second runner to the same width. This UHMW plastic is the exact same thickness as the miter tracks, and that won't work. I need some room between the edge of the miter track and the carriage. So I try sanding the track, and it's going to take way too long. I tried the belt sander, and it's way too slow also. So I'm stuck trimming it on my table saw. What's the big deal, you ask? Just watch. And now you know why I didn't want to cut it on my table saw. These aluminum shavings are like confetti, and even after vacuuming them up, I'll find pieces here and there for the next year. Seriously, I'm not kidding. Now I need to sand the sharp edges down, and for that I'm using these contour sanding grips. As with everything else, I'll put a link in the description below. And after some sanding, the edges are fine. I hit the ends, too. And here's how it fits now. There's plenty of room between the miter track and the carriage side. I repeat the process for the second miter track. Why didn't I do them both at the same time? When I figure that out, I'll let you know. The next step is to attach the runners to the centers of the carriage sides. It doesn't have to be in the exact center, but it has to be the same for both sides. I'll show you what I mean. Cut a spacer that puts the runner pretty close to the center, and we'll use a scrap piece for the other side to sandwich the runner. Clamp down a carriage side and the spacer, making sure they're even on the front. Make sure you label this edge as the front. I forgot, but I remembered in just a moment. Now clamp down the other piece with the runner sandwiched in between. Get the runner even at the top and bottom, and drill a countersunk hole in one end. Then drive the screw. Make it snug, but don't over-tighten it, or else the runner will expand a little and it'll bind in the miter track. Don't ask me how I know. Perfect. This is when I remember to label the front edge. You'll see why we need the labels in a moment. Label the front of the other carriage side and attach the runner the same way. And that's good too. So what's with the labels on the fronts? Here's the two carriage sides with both fronts facing forward. The runners are pretty much perfectly aligned because they both use the spacer on the front here. Now I'll flip one around. See how they don't line up? That's because my spacer didn't align the runner perfectly in the center. I didn't really expect it to. I'm just not that accurate. But if I have both front edges facing the same direction, then the runners should be pretty close to perfectly aligned, which we'll need in a moment. We need to figure out the distance between the carriage sides so we can cut the bottom and the top spacer. So take one of the sides with the label facing the front and clamp it into the miter track. Then do the same for the other and measure the distance. Cut a piece about twice the width of the carriage sides. We'll get the bottom and the spacer from this after we get it the right length. Always make sure the ends are square. You want to sneak up on the exact length, so start off with the length longer than needed. Check the length, trim a small amount off, and try again until you get it right. There, I hope that's right. Set your fence to the width of the carriage bottom. Mark one edge as the front and put that against the fence. When you're done, the piece with the label is the carriage bottom, and the other piece is the spacer. Now we're going to join the bottom to the sides, and the joints need to be flush. If we don't get the bottoms flush, when we add the router mount, the router will lean and the bits won't be perfectly perpendicular. If we don't get the edges flush, then the runners won't be aligned, and they'll probably bind in the miter tracks. So go ahead and attach the bottom to the sides, making sure you get all the joints, dare I say it, square and flush. If you're using the corner clamp, don't worry about the runners. The clamp won't hurt them. Once everything's attached, put the carriage in the tracks and put the spacer at the top and see how well it fits. I think this is going to work, but I'll have to wait until I attach the router mount to know for sure. I forgot that you should sand the bottom edges of the runners so it's easier to get them started in the miter tracks, so I ended up doing this later. If you're using a plunge router, this section is for you. If you're using a fixed base router, skip to the next section. Okay, let's see how to build the mount for your plunge router. First off, ignore the blue tape on my router. It's to help solve a problem I have with my router, which you probably won't have with yours. We're going to be attaching the plunge router to a piece of 1/2-inch plywood like this. And that means you probably can't change your router bit without removing the carriage from the lift. So you'll probably want to get a collet extension. I'm using this extreme extension, but there are cheaper extensions available, and I'll link some of them in the description below. This extension uses a hex key to tighten down the bit. You put the extension in your router and leave it there for as long as your router is in the lift. It extends the collet above the mount, where you can get to it to change bits. To get the length of your mount, measure the outside edge of the carriage, not including the runners, and add an inch or so extra. We'll cut off the extra when we're done. For the width, measure the widest diameter of your router base and add an inch or so. Then cut the mount out of 1/2-inch plywood. In the center of the mount, drill a hole for the collet extension. For the extreme extension, I cut 1.5 inch hole. Label one side as the bottom. Mark one edge as the front, and I like to put an arrow on the bottom pointing to the front. Anything I can do to help limit mistakes. Now you need to figure out where to mount your router. I'm placing my mount on some boards with the hole in between. I've got the extension lowered a little so I can center it in the hole. Once I've got it centered, I lower my router all the way down. I took out my springs in case you couldn't tell. Then I put the carriage over the router, centered in the mount. And then I figure out the best position for the router. My router has a speed dial, and I want it facing the front of the lift. I want some room between the carriage and the router handles in case I don't get it mounted perfectly. Now you need to mark where your router base goes so you can reposition it correctly. I have a flat side to my base, so it's easy to mark. If you don't, you'll have to figure something else out. So now we need to mark where the holes go for the mounting screws. I'm able to take my base off, so I use a drill bit about the size of the holes to mark the center of the hole locations. If you have a template, you can use that. If not, you might find one on the internet. If all else fails, you can take some thin paper or wax paper like this. Trace a reference point, like my flat edge, and shade it over the holes. So now I've got the mount on the table with the bottom up. I take the paper, turn it over, and position it on the mount. Remember to turn it over or you'll get the holes in the wrong place. Then mark where your holes go on your mount. We'll be drilling oversized holes, so it doesn't have to be perfect. Now we need to know what size holes to drill. If you don't know the size of your router base's threaded holes, you can either measure the hole or the screw with some calipers. My router base uses 5/16 inch bolts, so I'm drilling 3/8 inch holes, which gives me some wiggle room. First, drill the holes. Then countersink them. But I suggest you don't countersink them on the bottom, like I did. You really should countersink them from the top. Oh! I make sure I've got the mount positioned correctly, and I attach it to the router to make sure I got the holes in the right place. Which I did. What a surprise! Let's see how the carriage fits. It looks good, so I mark where it sits. The marks are just sanity checks. I did some measuring and marked where the holes go. Drill small holes through the mount so you know where to start drilling the pilot holes from the other side. I'm using a bungee cord to hold the spacer in place. Make sure the front edges are all facing forward. Then drill the holes and drive the screws. The spacer is still snug at the bottom, so that's good. It seems to fit pretty well. Let's trim off the excess. I don't know if you can hear it, but I'm reminding myself to measure to the inside of the blade. I'm checking it against the carriage, and it looks good. I already did the other side. Don't ask why I'm not showing it. Time to put everything back together. So let's see how it fits. The mount doesn't hit the tops of the miter tracks, so that means I cut off enough excess. But there's too much play at the top. No worries, I'll show how to fix this after building the fixed router mount because it applies to both types of mounts. If you're using a fixed base router, this section is for you. If you're using a plunge router, you can skip to the next section. Okay, let's see how to build the mount for your fixed base router. The main goal is to end up with a router that's perfectly aligned with the router lift. For a plunge router, it's relatively simple. All we have to do is attach the base to a board and put the board on the carriage. For a fixed base router, it's not as simple, but I've designed this mount to make it pretty straightforward. The router is clamped against these angled parts, which hold it vertically, as long as the angled parts aren't too far apart, that is, and as long as the angled parts aren't crooked, and as long as the whole assembly is square with the top. If you follow all my steps, then everything should be fine. If you ad-lib any, you're on your own. Start by cutting and laminating a couple of pieces of 3/4 inch plywood according to the plans. From this, we'll make 2 FRM-B parts and 2 FRM-C parts. While that's drying, cut the blank we'll use for part FRM-A a little wider than necessary. When the glue's had a couple of hours to dry, trim one edge. Then set the fence to the exact final width and cut the other side. Without moving the fence, trim part FRM-A to the same exact width. It's absolutely critical that these parts are all the same width. If you make a mistake, you can cut them a little narrower, maybe as much as a ½ inch, but any more than that and you risk the router not being stable. Now we can cut out the other parts. Make one end square, then cut out 2 FRM-C pieces of the same size and 2 FRM-B pieces of the same size. The sizes don't need to be exact, just reasonably close. Label the parts. For the FRM-B parts, put the label near the end, like this, so you don't cut it off in the next step. Not sure why I didn't label FRM-A yet, but you probably should, so you don't misplace it. Now cut the 45-degree mitered edges on the 2 FRM-B parts according to the plans. If you use a table saw, make sure you tilt the blade away from the fence. It doesn't have to be exactly 45 degrees, by the way. When I put the blade back to 90 degrees, I always double check it with a magnetic angle gauge. You can never be too careful. I think it's probably better to have the carriage bolt go through both FRM-B and FRM-C, like this, if you have a drill bit long enough and can get carriage bolts long enough. Otherwise, you'll have to settle for only going through FRM-C, like this. I'll do one of both just to demonstrate. For the shorter method, drill the counterbore holes for both FRM-C parts. Add the carriage bolt and tighten it down so the head pulls into the wood. Now glue parts FRM-B and FRM-C together. Use the following technique regardless of whether the carriage bolt's already installed or not. Put some wax paper on a flat surface. Freezer paper works better, I've heard. Put glue on one of the parts and lay FRM-C and FRM-B on their sides like this. If you've already added the carriage bolt to FRM-C, you'll notice it's closer to one side than the other. Put the short side facing inward. The back should be reasonably flush, but it's not critical. Put some more wax paper on the top. You should probably put a scrap board on top of the paper, which I'll do during the next glue up stage. Clamp the parts to the table and to each other. It's obviously important for the glued edges to be clamped together, but it's critical for the sides to be flush. So keep fiddling with the clamps until you achieve both goals. Then do the same for the other FRM-B and FRM-C parts. After a couple of hours, you can unclamp them. Hey, it's my wife! Peel off the wax paper and clean up any leftover debris, but be careful to keep the sides as flat and square as possible. If you haven't already added the carriage bolts, now's the time. Drill the counterbores according to the plans. Then drill the holes for the carriage bolts. I can't drill all the way through with my drill press table, so I finish with the handheld. Add the carriage bolts and tighten them down. I'm going to call these parts FRM-D for simplicity's sake. So glue one part to the end of FRM-A using the same technique as before, so we get nice, flush sides. The back edges should be reasonably flush, but honestly, they don't matter much. I used a scrap board this time. After an hour or two, remove the clamps and wax paper and clean up, like before. Now we need to figure out where to put the second FRM-D part. This is very important. I position my router next to the one FRM-D part and add a scrap board underneath the end of the router to keep it level. Then I slide the other piece over until it lifts the router off the back. It's very important that the router is resting only on the mitered edges. The mitered edges are what keep the router perfectly vertical. If the router touches the back, there's no guarantee it won't lean, like this exaggeration. So once you figure out where to place it, draw a line along the back. You'll probably want to extend it along the edge also. Then glue FRM-D inside that line. As long as you stay inside the line, you're good. This is our last 2-hour wait. Remove the clamps and paper and clean up. The squeeze out here is completely irrelevant. Cut the clamping board according to the plans. Then measure where the holes for the carriage bolts go and drill oversized holes for them. Put on the router and the clamping board and tighten the clamping board down with some knobs or whatever. Later on, I ended up switching to wing nuts because the knobs stick out too far. I'm using lock washers also. Make sure the router still isn't touching the back. If everything looks good, cut off the excess from FRM-A. Cut the top piece out of 1/2-inch plywood according to the plans. Put the clamp on the top with the back edges flush and the clamp relatively in the middle. Then draw an outline of the inside of the clamp. Extend these lines to the edge and cut out this section with something like a jigsaw or a bandsaw. I'm using my bandsaw. Cut either exactly on the lines or outside the lines. Just don't cut inside the lines where the top may press against the router, pushing it offline. Put the top on the clamp. It doesn't have to be absolutely perfectly square with the back or sides, but don't let the cutout part stick out over the clamp. And it's critical that it lies perfectly flat on the clamp. Attach it with screws. Consider where the carriage bolts are and make sure you don't drill into them. But don't put them too close to the outer edges because we may need to trim them in a moment. At this point, I screwed up because I thought I didn't need to read the plans. If you saw my post on Instagram, this is where that happened. Anyway, I patched the holes. Clamp down your router. Then mark lines across the top on both sides of the router shaft. Check to see if your clamp will fit in between the carriage sides with at least 1/4 inch gap on each side. Then take off the top. If it didn't fit, trim a little off the ends. I've got the spacer at the top of the carriage, and I'm using a bungee cord to hold it in place. Position the top on the carriage, lining up the lines you made for the router shaft with the runners on each side. It doesn't have to be perfect, but close is good. At this point, you need to attach the top to the carriage sides with 2 screws per side. You can either just wing it or measure it, it's up to you. For me, I already have screw holes in the carriage from the Plunge router lift, so I'll just match those. Now that the top's on the mount, let's see how it fits. It seems to fit pretty well. Now we need to cut off the excess on the top so it doesn't hit the miter tracks. And now let's put everything back together and see what happens. The mount doesn't hit the tops of the miter tracks, so that's good. But there's too much play at the top, which you already knew if you watched the Plunge router mount section. So let's fix it. I'm going to show you how to shim the miter tracks to eliminate this side-to-side play. It doesn't matter which type of router mount you have. In fact, from this point forward, everything applies to both types of mounts. Use some feeler gauges to measure how big the gap is. I've got 2 feelers here, 21 and 22 thousandths of an inch, and it looks like the gap is about 43 thousandths. So I put 4 pieces of painter's tape together and measured them, and they're about 19 thousandths of an inch. So if I put 4 on each side, I figured that'll be pretty close. So I put 4 pieces at the top of one of the tracks. It's covering the screw hole, but I'll just drive the screw through it. I double-checked with the carriage, and it still has a gap, which I expected, because I want to shim both sides as close to the same as possible. So I put 4 pieces of tape on the other track and test it. That looks pretty good, but it seems loose at the bottom, which it should be if I got everything parallel, so I add tape to the bottoms of the tracks also, and that's about right. With the weight of the router, the carriage seems to go down okay, although it might stick just a little. For now, I'll leave it like this. Next up is building what I'm calling the Fulcrum. Gotta call it something, right? It's this assembly here that the lever hooks onto. Cut out the pieces according to the plans. The hole goes in the middle near the top, so mark it. Clamp the two pieces together and drill the hole through both pieces. Glue the pieces together. I'm putting a bolt through the holes to make sure they stay aligned. Once they're all clamped up, you could go on to building the bearing assembly and then come back to this when the glue dries. But I'm going to keep this all together for the video. Draw a line on the housing base along the back panel. Then take the base off. Mark the middle of the back. We want the fulcrum right in the middle, so measure and mark where the sides of the fulcrum go. Position the fulcrum in place and outline it. Remember to keep it slightly away from where the housing back will be, so you can put everything back together properly. Then mark where you want to put the 4 screws. Using a small bit, drill the 4 holes all the way through the base. Clamp the fulcrum in place on the top of the base. Drill the countersunk holes from the bottom and drive the screws. Now put the bolt in with 2 nuts on the other side. Leave a little room so the bolt can spin, although this isn't critical. Put the base back on, and we're done with this section. This is the bearing assembly. It's just a couple of blocks of 3/4 inch plywood, some washers, and a skateboard bearing on a carriage bolt. These washers are just spacers to keep the bearing in place. Make sure the ones closest to the bearing don't touch the outer edge of the bearing or it won't spin. Cut the wood according to the plans. Mark the center of one of the pieces. We want to drill a hole through the center of both pieces. These are too small for me to clamp, so I drill through one piece, then use that hole to mark the center of the other piece and drill through it. Put the carriage bolt through one of the holes and tighten it down until the head gets pulled down into the wood. I'm using 4 washers, then the bearing, then 4 more washers. Then I use a washer and nut to tighten it down. Measure the width of the assembly. Oops, I forgot to add the lock washer. Take off the bottom of the carriage. Make sure you know which side is the bottom and measure the length of the piece. After doing some math, I mark where the assembly goes to get it centered on the bottom. After some more math, I mark where the pilot holes go. Get it all aligned and clamp it down. Then drill the countersunk holes and drive the screws. Reattach the bottom to the carriage with the front facing the front. And that part's done. Believe it or not, we're almost done. I'm making the lever out of red oak. Make it however long you think you'll need it. Cut it thin enough to easily fit in the fulcrum. Cut a notch in the end to go over the fulcrum bolt. Make it pretty close to the end so the end of the lever doesn't hit the back of the housing. Then clean it up however you want. Here's the one I'm currently using. So let's see how everything works. Let's try the fixed-based router first. Might be just a tad tight, but time will tell for sure. Let me switch to the plunge router mount. Well, it's definitely too tight. I could always just remove some of the tape I used for shims, but let's see what else we can do. My carriage is too wide, which makes it too tight in the tracks. The easiest way to fix this is to sand the runners. I thought that since the runners are plastic, it would only take a little hand sanding. Turns out this plastic is pretty darn hard. I finally ended up using my belt sander, which I did off camera. It's still just a little tight, but I'm going to stop here since I'm dealing with 2 different mounts. I'm going to use magnets to attach the door to the housing, so I'm attaching a couple of steel mending plates. Apparently I forgot to record part of this, which is okay, because this is not the most elegant way of doing this. I'm using some epoxy glue and the screws that came with the mending plates to hold them in. Now we need to cut the slot in the door for the lever. Figure out how far the slot needs to go, then cut out a slot about 1 inch or so wide. That looks pretty good. Time to attach the magnets. I'm using neodymium magnets about 3/4 of an inch in diameter, so I drill holes to match the position of the mending plates. I want to rough up one side of each magnet so the glue sticks better, but I guess using a metal file with magnets wasn't my best idea ever. Sandpaper works better. I add the glue and magnets, put on some painter's tape, and clamp them down for 20 or 30 minutes while I have lunch. Well, that works pretty well. On my original lift, I used an angle grinder to make the tops of the screws flush with the mending plates. I'm going to use a piece of old bicycle inner tube to keep the dust from flying out through the lever slot. I got this from a local bike store. I just walked in and asked if they had an old inner tube they were going to throw away, and they gave it to me for free. Last thing is to cut out a slot for the power cord. Here it is with the fixed base router. And here's the plunge router. I'm not going to talk much about dust collection because it's a lengthy topic all on its own. But the plans show you how to make the solution I showed in the previous video, which is to drill a bunch of holes in the bottom and make this dust drawer. The drawer sticks to the bottom with magnets, if I turn it the right way. The drawer has a baffle, which sits in angled dados to help direct the dust to the dust port. I use an adapter like this to attach the dust hose. If you want to make one of these yourself and you aren't sure how to cut the dados for the baffles, I just use my crosscut sled like this, making 2 passes to get the dado wide enough. The dados don't have to line up perfectly because the baffle is flexible. I can't really tell you how to attach the lift to your router table. Everyone's different. But as I showed in the previous video, here's how it works with mine. The last thing we need is a way to lock the router to a specific position. The plans show how to make this simple clamp, which I use on the outside door underneath the lever. The weight of the router keeps it in place, and it's simple to move up and down. If you don't have an outer door, I'll show you another option in the section on the mini router lift table in just a moment. To check the alignment, I use this 1/2-inch steel rod I got from Amazon and a speed square. If the router's not aligned correctly, the plans show you various places you can add some painter's tape to make it square. Don't check it against your router plate, which may not be level. Only check it against the table top. And make sure whatever square you're using is actually square. Trust me on this. So what do you do if you don't have a router table yet? You can turn this router lift into a mini router table. The plans tell you exactly how to build it, but let me give you an overview. By the way, the table is surprisingly stable by itself because it's so heavy, but it's probably safer to clamp it down somehow, like I've done using this old Black & Decker workmate. So I framed the top of the lift with a piece of 1/2-inch plywood. I cut the middle out so I can remove the carriage easily. The top is a piece of melamine. It has a hole in the middle large enough so I can change bits without having to remove the top. On the underside, it has 4 blocks that squeeze the edges of the frame, and 4 clamping bars that slide over the frame. I recessed the screws, so if I lay the top down on something like my table saw, the screws won't scratch anything. When I put the top on, it slides easily in place, and all I have to do is slide the clamping bars over and tighten them down. Since I don't have anything I can put the lever clamp on, like an outer door, I made this rig. It attaches with magnets, and it's on there pretty good. The clamp has a piece that goes under the lever, and it's good and stable when locked. If you have a table, but you don't have an outer door, this should give you some ideas of what you can do for a clamp. I attached this power switch in a place that's easily accessible. If you have a router table, you've got to have an external power switch. And that's pretty much it. I can raise the lift and add a router bit. It works just like you'd expect. No dust collection, of course, but you could probably make a fence with a dust port if you really wanted to. Speaking of fences, you can make a quick and dirty fence by taking a board and cutting out a section of it like this. In case you don't already know, feed the stock from your right to the left. There are some rare exceptions, but in general this is the safest method and will give you the best cuts. Never get the stock between the fence and the bit, even with the bit barely raised up, like here. Don't do this. And finally, always think about what would happen if the stock suddenly got ripped out of your hands. If your hand's over the bit, blood. If your hand's off to the side, possibly blood. Use a push block. They don't bleed. Well, I think I've talked long enough, don't you? Don't forget that the plans are available on my website. Please give this video a thumbs up if it was helpful, and consider leaving a comment. Thanks! Check out the description for links to products seen in this video. Just scroll down, click Show More, and scroll down until you see the links. And if you like what I do here, click that subscribe button. And don't forget to ring that bell to get notified about new videos. Thanks!